So in this lecture, we will start with superposition theorem. I hope you guys have heard the word superposition before. In different contexts maybe, like in forces we have done superposition, like in waves we have done superposition. So here in this video, we will do superposition theorem on DC networks. So if I explain in very simple words or in a layman's language, we can say that an element or circuit obeys principles of superposition if the net effect of causes is equal to the sum of their individual effects. So it is in a very layman's language, but if you ask for the statement of superposition theorem, then here we have for a linear bilateral network containing several sources, the current through or voltage across any branch in the network is equal to the algebraic sum of the currents or voltage of each individual sources considered separately with other sources made inoperative, that is replaced by resistance equal to their internal resistance. So here why we apply superposition theorem? We apply superposition theorem when there are several sources. Like we all know that if in a numerical or in a DC network, if there are several sources, it becomes complicated to solve. Okay, so superposition theorem makes it easier to solve the numericals here. So in this, if there are several sources, we only consider one source at a time, and when one source is considered, the other source is made inoperative, that is by putting the resistance equal to their internal resistance. So the sources are of two types, we know, voltage source and current source. Here in this lecture we are only dealing with independent voltage or current source. So independent means like the voltage of the voltage source will not depend on any voltage of any branch of the circuit. So you have to note down this statement of superposition theorem, and then write this note because it's very important for solving any numerical. So if we have a voltage source, independent voltage source, so I'm drawing a independent voltage source here, then if in the superposition theorem we are considering any source, then the other source have to be made inoperative. So to make a voltage source inoperative, we have to replace it with a short circuit. And for a current source, and to replace a current source, we have to replace it with a open circuit. So you might have this question, why we have to replace this voltage source with voltage source with an short circuit and current source with a open circuit, as the voltage source has zero internal resistance. So I'm writing it short because the board is quite small. So here, so it has zero internal resistance. So to represent it, we replace it by a short circuit. You know the meaning of short circuit. The short circuit, it has zero resistance. So therefore we are replacing this voltage source with a short circuit. And in case of AC, current source, we are replacing it with open circuit, since in this current source we have infinite resistance. Current source always has infinite resistance. So to represent it, we replace it by a open circuit. So you have in the superposition theorem itself, it has been written that the other sources are made inoperative by replacing by their internal resistance equal to the internal resistance. So here we have why we are replacing the voltage source and the current source with short circuit and open circuit respectively. So this is the reason. I hope you have understood till now. So let's start with a numerical, then your concept will be more clear. So I will write down the question, so please wait. So here we have to find out the voltage across 4 ohm resistor. So in the question we observe that there are two sources present. One is a voltage source and other is a current source. So we can start with any of the sources. Here I am starting with the 6 volt source, which is independent in nature. So if we consider the 6 volt source, then we have to make this current source inoperative, since we are considering the 6 volt source. So let's draw the diagram. So here we are replacing or making the current source inoperative. So we know the current source is always made inoperative by open circuit. So here we are drawing an open circuit. It was 8 ohms here and 4 ohms here and 6 volt. So now we here in the question you have already seen, we have to find voltage across this 4 ohm resistor. So we are considering voltage V for this particular circuit, for this 4 ohm in this circuit. So here we need to find out this V. So in order to find out this V, we first need to calculate the current we see. So it's easy to find out the current because only this 8 ohm and 4 ohm are in series. So we know that if it is in series, so the total resistance will be 12 ohm, and the voltage we know is 6 volt for the source. So here we have the current rate, that is 6 by 12, like by Ohm's law we know V equals to IR. From there we find out that current flowing is 0.5 ampere. So we need to find the voltage across the 4 ohm resistor. Actually the current direction I should write. So here we find out the voltage, V equals to I into the resistance. So I is half or 0.5, and the resistance, sorry, it should not be I should not have written total resistance, sorry, I am extremely sorry. It will be the resistance 4, as we are finding the voltage across the resistance 4 ohm. So the voltage will be 2 volt across the 4 ohm resistor when the 6 volt voltage source is considered. So now we have solved for the 6 volt voltage source. Now we have to consider the 3 ampere current source. So here we have the diagram for the question. So now we have to consider this source. So to consider this source, then this 6 volt voltage source we have to make it inoperative. So here we are replacing it by a short circuit. So let's draw the diagram when we are considering the 3 ampere current source. So considering 3 ampere source, okay. So we have to draw the diagram here. So here the scenario is different. We see this, there is a 6 ampere current source. So since we need to find out the voltage across this 4 ohm resistor, therefore we are assigning a voltage to it, which we have to find out. V1. So now to find out this V1, we have to first find out the current I through 4 ohm. So to find out this current I, we all know about the current divider rule. The current in this 4 ohm resistor will be equal to the total current into the resistance of the other arm here and the total resistance by the total resistance. So current I will be 3 ampere into the resistance 8 ohm. Total resistance is 12 ohm here. So the current will be 2 ampere. So our aim was to find out the voltage. Here the voltage V1 will be I into 4. Therefore I here we have found out 2 into 4, that is 8 volt. So now we have found out the voltage across 4 ohm for 6 volt voltage source considered separately and 3 ampere current source considered separately. So now by superposition theorem we will add this. So here by superposition theorem, the voltage will be equal to V plus V1, which we have found out in this video. So V total across the 4 ohm resistor will be 10 volt. So this question is solved. I hope you have liked this video. We will solve more questions on this superposition theorem in the next upcoming lectures. So if you have any doubt, any question related to this topic, please do comment below in the comment section, and don't forget to subscribe the channel and press the bell icon. So in the next lectures, obviously there will be more numericals. In one numerical you can't understand the whole thing, so there will be different types of numericals in the next lectures. So subscribe and press the bell icon to follow this channel. Thank you.